Hey everyone, my name is Gage Funk, and today we're going to explore one of the most fascinating and important tools in forensic science, blood spatter analysis. Blood spatter analysis allows forensic investigators to reconstruct the events of a crime scene. By studying the patterns and characteristics of bloodstains, experts can piece together what happened before, during, and after a violent incident. These patterns are more than just stains, they're clues. So now that we've introduced blood spatter analysis, let's take a look at the key points we'll cover in today's presentation. First, we'll start with a general overview of blood spatter analysis, explaining the basic principles behind this field. Then we'll discuss the uses of blood spatter analysis at a crime scene, how investigators use blood patterns to uncover critical information about the events that transpired. After that, we'll look into the types of blood detection methods employed at crime scenes, from visual examination to chemical tests. Finally, we'll dive into the different classifications of blood spatter and how each one can tell us something unique about the crime. Let's begin with the first topic, blood spatter overview. Blood spatter is the pattern or distribution of bloodstains that are created when blood is subjected to force. This force can come from a variety of sources, such as a gunshot, a stabbing, or blunt force trauma. Each type of force leads to distinct blood patterns. For example, a high-velocity impact like a gunshot creates fine mist-like droplets, while a stabbing might result in larger, more irregular splashes. Understanding these patterns is crucial because they provide investigators with key information about what happened at the crime scene. The study of blood spatter is also known as bloodstain pattern analysis, or BPA. Blood spatter analysis is not just about understanding the patterns of blood, it's about uncovering the story behind those patterns. The size, shape, and spread of bloodstains at the crime scene provide critical clues that help forensic investigators reconstruct what happened. In essence, blood spatter analysis provides investigators with the ability to reconstruct the crime, and sometimes it's the only way to answer the crucial question, what really happened here? Let's take a closer look at how blood is detected and analyzed during a forensic investigation, even when it's not visible. Visible blood detection methods are techniques used to identify blood at a crime scene that can be seen with the naked eye or under special conditions. Let's start with the Kastle-Meyer test, a presumptive test that uses a chemical called phenolphthalein. When this reagent reacts with the hemoglobin in blood, it turns pink, confirming the presence of blood. The Kastle-Meyer test is a quick, affordable, and effective way, making it a popular choice for field investigators. It's especially useful when looking for small bloodstains that aren't immediately visible. However, there are some drawbacks. The Kastle-Meyer test can produce false positives, especially when reacting with other substances containing peroxidase-like properties such as certain plants or chemicals. Additionally, it can't differentiate between human and animal blood, which may complicate investigations. Next, we have the hydrogen peroxide test. This method detects blood by reacting hydrogen peroxide with an enzyme called catalase, which is found in high levels in blood. The reaction produces visible bubbles indicating the presence of blood. The hydrogen peroxide test is highly sensitive and can detect even trace amounts of blood. It's quick and inexpensive, making it another valuable tool for field investigators. However, like the Kastle-Meyer test, it's not without its limitations. False positives can occur if other substances with catalase, such as vegetables or bacteria, are present. And while it confirms the presence of blood, it does not distinguish between human or animal blood. Both of these tests are essential for preliminary blood detection, but to confirm the origin of blood, further testing, such as DNA analysis or blood typing, is necessary. Now let's explore some of the methods used to detect invisible blood, blood that isn't immediately visible to the naked eye, but can still reveal critical evidence. First up, we have infrared detection. Infrared cameras detect heat emitted from objects, and then they can be used to reveal hidden bloodstains that have a slightly different temperature than the surrounding surfaces. This method is especially useful for identifying blood that may be hidden under carpets or in places where cleaning has been attempted. The main benefits of infrared detection is that it's non-invasive and can help locate bloodstains that are otherwise undetectable. However, it has its limitations. Infrared cameras can be costly, and the blood must be in a specific condition for the heat signature to be noticeable. It is also less effective on surfaces that retain heat evenly. Next is luminol, a powerful chemical used to detect blood even if it's been cleaned or is no longer visible. When sprayed on a surface, luminol reacts with the iron in hemoglobin and emits a blue glow in the dark, revealing the presence of blood. The major advantage of luminol is its ability to detect trace amounts of blood that may have been wiped away or diluted. However, luminol isn't perfect. It's a very sensitive test, which means it can produce false positives when reacting with other substances that contain iron, like rust or certain cleaning agents. Finally, let's talk about hydrogen peroxide. Though we've already mentioned it as a visible detection method, it's also effective in revealing invisible blood. When applied to a surface, hydrogen peroxide reacts with blood to create a bubbling effect, even when the blood is faint or not visible to the naked eye. Hydrogen peroxide is quick and easy to use, and it can be effective in detecting small amounts of blood in places where it's otherwise hard to spot. However, like with visible blood detection, it's important to note that false positives can occur if other substances with catalase are present. Invisible blood detections like infrared, luminol, and hydrogen peroxide provide investigators with essential tools to uncover hidden evidence. While each method has its strengths, they must be used in conjunction with other tests to confirm the results and ensure accuracy. Now that we've covered how blood can be detected, let's move on to an essential aspect of blood spatter analysis, blood spatter classifications. We'll be looking at three main categories of blood spatter: low velocity, medium velocity, and high velocity spatter. Let's begin with low velocity blood splatter. As the name suggests, this type of spatter occurs when blood is subjected to a low amount of force, typically around 5 feet per second or less. Low velocity spatter results in relatively large, round droplets with little to no tailing or directionality. This type of spatter is often seen in situations where blood is dripping from a wound or from a victim who is stationary, such as when a victim is bleeding from a head injury or after being stabbed. Low velocity spatter is typically found in pooled blood or on surfaces that have been spattered gently, such as the victim's clothing or on floor around them. The stains are usually about 1 to 4 millimeters in diameter. Now, let's move on to medium velocity blood spatter. This type of spatter occurs when blood is subjected to moderate force, usually between 5 to 25 feet per second. Medium velocity spatter is typically produce smaller blood droplets compared to low velocity spatter, often ranging from 1 to 4 millimeters in size. The droplets may also show more directionality, meaning they'll have tails or an elongated shape that can help investigators determine the direction from which the blood came. This type of spatter is commonly associated with blunt force trauma, such as being struck with a bat or stabbings. Because of the speed and force behind medium velocity spatter, investigators can use the pattern to help reconstruct the location of the victim, the type of weapon used, and the nature of the attack. The presence of medium velocity spatter can indicate that the victim was moving at the time of injury or that multiple blows were delivered. Finally, let's examine high velocity blood spatter. This type of spatter occurs when blood is subjected to extreme forces, usually at speeds greater than 100 feet per second. High velocity spatter typically produce very small droplets, often referred to as mist. These droplets are typically less than 1 millimeter in diameter and can be scattered over a large area, sometimes even several feet from the point of origin. This type of spatter is most commonly associated with gunshot wounds, explosive injuries, or other high-impact events where the force of the injury causes the blood to be dispersed rapidly in tiny droplets. High-velocity blood spatter patterns are crucial in understanding the nature of the attack, especially in cases involving firearms. The spread of the droplets, combined with their size and direction, can provide investigators with key insights as to the angle of the shot, distance from the victim, and the location of the shooter. Thank you for all your attention and interest in this important topic of blood spatter analysis.